Good day, I'm Molar Mass. Welcome back to our channel. Today we're going to be starting with our section 2 of the 2017 study guide of our CIR 113, which is Chemical Engineering 113 module of the University of Pretoria. We're going to be doing an introduction to a couple of the section 2 concepts. We're going to be looking at molar mass, density, bulk density, and also SG. And then we'll do the other ones on our next video. The very first concept that I want us to look at is the molar mass. So the molar mass actually has units of molar mass. It would be grams per gram mole or kilograms per kilomole or even pound per pound mole, etc. So usually when you get the molar mass, it actually just be put up as a number, but it does have units. It has your grams per gram mole, kilograms per kilomole, pound per pound mole, or whichever units they might be. Just to make it a little bit clearer, let me take a little bit of an example. The molar mass of N2, the molar mass of N2 equals to 14 by 2 equals to 28. Now, the 14 is taken from the periodic table where you look at the nitrogen and you see that its molar mass is 14. But your nitrogen as written here is actually N2, so it's nitrogen by 2, so it becomes 14 by 2, then that makes it 28. Usually just left as 28 or whatever number. It never really, they hardly put units there, but we know in our minds that it actually has units. So yeah, that is our molar mass. A second one that I want us to talk about is density, which is equals to mass per unit volume. Now, in the context of density here, you actually take a substance. If you were to calculate it in practical terms, you can take the substance, then weigh it and get the mass of it. And after you get the mass of it, then look at that, calculate the volume of that substance that you have. So, and then you calculate, you get the mass over the volume. So density is basically mass of a substance over its volume. Now, another variety of density is called bulk density. This one is equals to mass per volume. I'll just try explain it. I like easy explanations. Let me just say over the container that the substance occupied. This one works a lot with containers. Let's say you have, for instance, you have a bucket full of concrete. You calculate the mass of the concrete, and then you also calculate the volume of the container. So if you have the mass of the concrete, and let's assume that it's full. Let's say you have the mass of the concrete, and you calculated it, and then you also know the volume of the container. Then you can actually get the bulk density, because it's actually mass all over the volume that the substance is occupied. That is our bulk density. Another variant of density is SG. It's also mass per unit volume. One important aspect about SG that one needs to understand is that it has units of SG are kilograms per liter. So this is very important to know. So when they say the SG of a substance is actually 6.3, 2.6, 5.2, They basically are saying, for instance, in the study guide, there's a portion where they actually mention that the SG of a substance is actually 2.6. They are basically saying the SG of that substance is 2.6 kilograms per liters. Now, if you check in the study guide, they actually decided to express it as 2,600 kilograms per meter cubed. Now, they did a calculation here without explaining at the back of their minds. Of course, it's something that you can actually do by default the more you after a lot of practice, but just a little bit of an explanation of how did they reach 2.6 kilograms per meter cube if these are the units. Let's say Sg equals to 2.6 kilograms per liter. So what they did was they just decided to convert the volume, which is in liters, into meter cube, and which is multiplied by 1,000 liters all over 1 meter cubed. Let me just write here, it's the i.e. 1 meter cubed equals to 1,000 liters. Yeah, 1 meter cubed equals to 1,000 liters. Yeah, let me just highlight that it comes here. So that's basically what they did, and then they were left with 2,600 kilograms per meter cubed. So that's actually what they did. That's why they can translated the 2.6 into 2,600 meters cubed. So if they tell you the SI of a substance is whatever number, just put these units. And if you know that it's actually kilograms per liter cube, you can actually convert it to whatever units you want, either it's SI or it's American system of units, as long as you know that the standard SI units is this. So yeah, that's something very much important that you needed to understand. So yeah, well, this is actually what I wanted to discuss just in this part. I'll make the second part of the introduction to section 2 concepts where we'll discuss concentration. And yeah, it also has a lot of varieties, but we'll find some time. I'll make a video explaining each one of those varieties. So thank you, and we'll meet again on our next video.